Okay, we'll get started here. Hello and welcome. This is welcome to the newest installment of Server Technology PowerTips Live. This is a Legrand webinar series designed to provide live technical support demonstrations, as well as the opportunity to ask questions and have discussions with our team and fellow participants. My name is Ellie Byrne. I'm a marketing specialist at Legrand, and I'm joined here by our host, Bruce Auclair, our senior technical support engineer at Legrand. In today's live technical webinar, we'll be discussing SNMP versions, downloading MIB and structure overview, finding SNMP object IDs for inlet and poles or phases and outlets for different sensors. Feel free to post any questions in the Q&A and the chat sections throughout the presentation, or wait till the end when we have open microphone access for our participants for questions and discussions. If you have any other pressing issues, you can visit servertech.com/support. And with that, I will pass the floor to Bruce to begin.
Okay, well, good morning or afternoon, everyone. And if you attended the previous meeting or webinar, welcome back. Jump right into this. As Elizabeth said, topic is all about SNMP. In particular, today is about the Server Technology Pro 1 and Pro 2 series products. It's our fourth generation product line. So we call that Sentry, SENTRY 4. And we're going to discuss those today. There is a webinar tomorrow that will discuss Server Technology Pro 3 and Pro 4X products that are a Xeris-based technology platform. But today the topic concerns Pro 1 and Pro 2 products, which run firmware version 8. In particular, the current release is 8.0Z as in zebra, and everything that we look at today is running the latest release. So just a general overview of SNMP. It stands for Simple Network Management Protocol. It's an primarily integer-based protocol that allows users to manage devices on the network by collecting information, controlling, configuring, and receiving alerts when events occurs, what's known as a trap. So we have an SNMP manager is typically the way things work. There's a variety of managers out there and a variety of DCIM monitoring tools that rely on SNMP as the primary means of collecting data. And the agent is, in this case, what we sell is the PDU. So we've got an SNMP manager collecting data from different PDUs, agents, and in turn they can configure items on those agents. They can pull the objects on those agents to gather data, and they can receive automated alerts, what are known as traps from the agents when events, simply for an example, a circuit breaker tripping on a PDU, the PDU can automatically notify the SNMP manager that that event has occurred. So SNMP, there's two key elements particular to the server. Well, all SNMP implementations involve a MIB, a management information base. And in the case of server technology, we also publish an object identification tree, an OID tree. Other manufacturers out there, you rely on tools to generate a tree, but as I will show you, we actually publish a text file that is the object identification tree in addition to the MIB. The MIB is a text-based file that defines the structure of supported objects in an SNMP device. And the MIB is an enterprise level object. That is, the MIB doesn't define what the PDU does. It defines all the possibilities of what the PDU might support. You have to perform a MIB walk against a particular Pro 1 or Pro 2 system to identify which objects are supported by those particular models. Simple example is if you have a PDU that is switched, you're going to have objects that would not exist with a smart PDU. With a switched PDU, you will have objects particular to controlling outlets. And then another example is We have products that contain simply per inlet power sensing that measures everything there is to measure at the aggregate or the input level. And then we have other products that have also contain a per outlet power sensing POPs. And so in the case of a product with POPs, you will have plenty of objects that do not exist in a product that contains only PIPs. So the MIB itself defines all possible objects. You have to run a MIB walk against a particular model or models in order to find out what objects those models support. And then an OID, an object identification, is a string of dot separated numbers that uniquely defines an object. We'll take a look at those in a moment. But first, it's just to define where you find those. The fourth generation server technology PDUs, which are the Pro 1 and the Pro 2 series, the private enterprise MIB and OID tree are found here. Well, this is a link to it. I'm going to jump over and show you where that's found on our, starting at our home page. So if you go to servertech.com, you're going to just hover your mouse pointer over the word support at the top of the list and scroll down to the third item. You will find MIB and OID tree downloads. And from there, you've got a variety of products. What we're talking about today is this category, the Pro 1 and the Pro 2 series. The CDU series are an older third generation end of life product line that is not being discussed today. The Pro 3X and the Pro 4X are the Xeris platform technology-based products that will be discussed at tomorrow's webinar. So the Pro 1 and the Pro 2 series PDUs, we have a zip file that contains both the MIB and the OID tree. I've already got both of those open. Or I thought I did. I've got one of them opened. So let's just take a quick look at the MIB. Jump back. So key elements of the MIB is that they have common definitions. And by that, I mean, jumping back, near the beginning of the MIB file, we have this section here, common definitions. These define 23 different integers that relate to a status, and that is, these are the 23 possible integer responses for status for objects where you're querying status of the object. As mentioned here, there's 23 of them. The MIB also defines the integers for all the SNMP set write actions. SNMP set is an action that tells the PDU to either do something or it configures an object on the PDU, such as naming an outlet or naming a temperature sensor. And the MIB defines those throughout its structure in various places. I like to use this as an example, the outlet control action. So it defines when you are using, in this case, an outlet control action, you're sending an SNMP set command to tell an outlet to turn on, turn off, or reboot. The MIB defines the possible integer values and what they relate to. So if you want to send an instruction to switch an outlet off, there's going to be an integer identifier using a number 2 to turn it off. You've got options of reboot, none, and on. On and off are going to be typical. There is abilities that we're not going to talk about today where you can queue outlets to turn on or off, and that's useful when you're going to send a bunch of commands to switch outlets off. You can only send individual commands, but you can use the queue options to send multiple commands and have a final command that then tells all queued objects to perform that action at that time. Finally, the MIB defines the units value for a number of different objects, more commonly known as a unit of measure, in the Xeris product platforms, I think they call it a decimal digit, but it effectively tells you, because all the responses for SNMP for values of objects are integer based, it tells you how to adjust where the decimal point is located. And so an example there would be, okay, so when we query an object, that would be using an SNMP get command. For example, we want to find the input current value, either a single line value if the PDU is single phase, or a line value for one of three phases if the PDU is three phase. There is an object that allows us to do this, and the units is what I'm talking about presently. In the case of line current, the value is 10th amps. So that means if you get a response of 32, that means 3.2 amps. It does not mean 32 amps. So you have to move decimal point 1 over, and a 32, it relates at that point to 3.2. Okay, in the OID tree, this defines all of the variable binding indexes. I call them variable bindings. Other people call them indexes. I just called it variable binding indexes. Let's take a quick look. Okay, at the very top of the object identification tree, these are the variable bindings. They very much follow the structure of a PDU, at least if you look at the web GUI. I'll show you what I mean by that. We have in the monitoring section the hierarchy of the system, which at the highest level is the unit, then chords, lines, phases, OCPs, which stands for overcurrent protectors, branches, outlets, groups, and sensors. And if we take a look at the OID tree, we find that same overall hierarchy over here on the left, and then we find what the possibilities are as far as an integer value to relate to that particular object. So a unit being an actual PDU, the system actually supports up to 6 PDUs, could exist together within a single system interface. Presently, server technology supports only 4. That is, one primary PDU can presently support up to 4, but overall the system was designed that if we ever do it, we could make it support up to 6. So when we look at certain objects further down where you find a unit variable at the end of the OID, that has to be replaced by a value. In this case, the unit identifier can be a value 1 to 6. As I just mentioned, in reality, presently it's only up to 4, but the system supports up to 6. So we're going to find a various different indexes or variable bindings for different objects where you have to specify either just one index, possibly 2 indexes in cases of the chord. And then you can get down further, you're going to have up to 3. And when you get to the outlet levels, there's going to be, I think, also 3 as well. Anyhow, the object identification tree identifies all the variable binding indexes at the very top of the OID tree. And as I just showed, it shows them specifically for every object. For example, with the line current, you had to specify a unit and then a line. And then overall, it defines the full digits-based strings for objects in a much more friendlier format than the MIB file. If you're just strictly looking at the published MIB file, it Takes quite a bit to put together in your head the entire string. If you were to start from the top and work all the way down through to your particular object, it's much easier to take a look at the OID tree. Everything particular to server technology, PDUs will have a string starting with those digits. The next identifier, in this case 4, this is because this is a 4th generation, the Pro 1, Pro 2 series are 4th generation PDUs. So we have created a MIB specific to just the 4th generation Pro 1 and Pro 2. And then from there, it breaks down all the way to the finite object. So there's a variety of ways that you can use this text file to determine what object or what string you need to use. That is, what OID you need to use if you're interested in finding something. Just a simple example would be input cord active power. That is watts. You would start and work backwards. Watts is going to be based upon, in this case, at the input cord level, it's going to be based upon a cord that is particular to a unit. So if, for example, this were a standalone primary PDU and you want to find the active power, the total active power or watts through that entire PDU, it's a single corded PDU. You'd have a 1 for the cord. You'd have a 1 for the unit. Unit being a 1 is primary. Unit being 2 is a first link unit. Unit being 3 is a second link unit, and unit being 4 is a third link unit. So you're going to end with a 3.1.1, and you just work your way backwards. You'd have a 3.1.1.3.1.1, and you can just scroll backwards all the way up until you get to the beginning. So you can put it together simply through the OID tree that we publish, but there's much easier ways to achieve the goal that we'll see in this presentation. Okay, and then oops. Yeah, and as I mentioned moments ago, it does provide a condensed view, a much simpler way of versus the MIB of viewing the object categories and their subtrees. And jumping back to the MIB, just what I just called the subtree would be different categories, system, units, and then within each of those categories, you have different tables. You have a configuration table. You have a monitor table, which is for polling objects that you're interested in, such as line current, phase current, branch current, and it all breaks down into different tables, and the OID tree lays those out for you. Much simpler than looking at the MIB. But again, there is better ways, and we'll move on to that. Okay, so popular SNMP tools, there is built into most operating systems something called Net SNMP. It's been around for many years, built into Linux and Unix and Mac operating systems for a very long time. More recently, it is now included in Windows. It does have to be enabled in Windows, but it is available to be enabled, and it is a tool that we will see some examples of today. Particular to Net SNMP, if that is your tool of choice for getting objects using SNMP get commands or walking a MIB using an SNMP walk command. The thing that you need to remember if you want to use a more verbose command, and I typoed in here, you need to get the Sentry4 MIB file. I showed you where you can get that already on our website. You download the zip file, extract the contents where you will have both a Sentry4.mib. Oops. You'll have Sentry4.mib. I am hitting the wrong button. And you'll also have a Sentry4.oid tree.txt. The MIB browser tools and SNMP doesn't use the OID tree. You simply load the MIB. Particular to Net SNMP is that you need to rename the Sentry4.mib to Sentry4. That's where I typoed, mib.txt and you place it in this folder in your Windows directory. And that allows NetSNMP to convert string-based responses or string-based commands into more verbose commands. We'll see what I mean a little bit later on. And then another popular tool, my tool of choice, is something by the name of iReasoning MIB browser. We're going to look at that today. I have a professional edition, but as a good note, there is a personal edition that is entirely free with no limitations as far as expiration, but it does not support SNMP version 3 and it only allows you to load 10 MIBs. I'll just show you quickly. You can go to that website and you'll find a free download. And if you take a look at this chart down below, the personal edition does have some limitations. It's entirely free, however, does not support SNMP version 3, and it is limited to 10 MIB downloads. Professional edition has very few limits. And then NetSNMP, if you want to learn more about NetSNMP, that is their website. Again, it is built into Windows now if you're a Windows user, but you have to enable it. And you can just Google what I've got up here, enable NetSNMP Windows, and you'll be able to enable NetSNMP if you're a Windows user, which in the case of NetSNMP, it's a command line interface. Okay, now before you can use SNMP with the Pro 1 and Pro 2 PDUs, it does need to be enabled out of box since basically January 1st, 2020. Due to California Senate Bill 327, the PDUs ship with all SNMP disabled. That is both SNMP version 2, which in the case of the Pro 1 and Pro 2 is actually version 2 Charlie, and version 3. They are both disabled by default, so you do need to configure the PDUs to enable SNMP. I'm going to show you how to do that or where to do that in the web GUI. And then you can optionally configure trap destinations. That is, if you wish to automatically be notified upon events such as a circuit breaker tripping or temperature exceeding a threshold, you need to tell the PDU where to send that trap, and that's going to be your SNMP manager. Excuse me, I had to take a sip of water there. If you are enabling SNMP version 2, there's a couple extra steps. You need to configure a get community string. It's effectively a password of sort. It's a password that will allow you to read objects from the PDU. It's a read-only password, if you will, and then optionally, if you intend to use SNMP to configure items and or control items, such as switching an outlet on or off, if it's a switched PDU, you would also need to configure a set community string. And then for SNMP version 3, which is recommended and preferred due to security, you would have additional steps of configuring up to 8 users, access methods for those users, and effectively the passwords for authentication and privacy. We're going to take a look at that in a moment. One note is that if you choose SHA auth and AES for privacy, it's not mentioned anywhere in the server technology documentation. Literally nowhere that I've found. A good note is that in the case of AES, it's AES 128, not 256 or something else. Let's take a look at a PDU. Hang on, there we go. Okay. So, well, that's weird. If you do have to be logged in at administrator level, and to enable SNMP, you need to go to configuration system and then network. I'm sorry, just configuration network. and some odd behavior. Okay, configuration network, SNMP. You can use, I'm going to demonstrate only SNMP version 2, so I've already enabled SNMP version 2 just to save some time, because a restart is needed when you make this change. It's a soft restart, by the way. If it's a switched PDU, outlet states are not affected, and I've pre-enabled it to save some time. If you wish to enable SNMP version 3, you've got that as an option. Most common would be a user would enable SNMP version 3, not enable SNMP version 2. But for simplicity today, I am using SNMP version 2. As far as the OID strings or the object identification strings, they are the same overall, whether you're using version 2 or version 3. So the purpose of this presentation today is not affected by choosing version 2 only. So I've configured, in this case, enabled version 2. I've configured a non-secure get community string of public and a set community string of private. Those are both blank by default. You have to enable SNMP version 2 and then create one or both of those. At the very least, you need a get community string. If you wish to write objects or control the system, you need to also put in a set community string. Optionally, you could do just a set only community string because it is read and write. And then if you intend to have the PDUs automatically send notifications of events to an SNMP manager, you do want to define a trap destination. I've defined a trap destination of that address, which is the laptop that I'm using to present today. So we can see that later on, we'll see the PDU successfully send a trap when I switch an outlet on or off or trip a circuit breaker. Now, if you do configure SNMP version 3, you've got an additional step, configuring the version 3 users, and that's going to require you go to this page, put in a username. I'm not going to do it. Choose what access they have. Most common would be read and write, and then you proceed to choose your method. The highest security method we support is SHA for authentication, AES, again, AES 128 for privacy. And after you do that, you do have to put in a password for both the authentication method and the privacy. Again, I'm not going to bother doing that, but that is required. SNMP ships disabled in the PDUs, so you do need to enable SNMP to begin to do what we're going to look at next. And as mentioned, the final step was a restart. In the web GUI, you would have gone to the Tools menu in the bottom left, used a drop-down, selected a standard restart, and click Apply. And that takes about 75 seconds to restart, and then you should be able to begin communicating to the PDU by SNMP. All right, so let's get to it. That's gonna jump and start showing you a couple of things that you can do, and then I'm gonna open it up and ask you what you'd like to see. We're going to start with an SNMP walk. That is, as mentioned previously, ultimately one of the first steps so that you can learn what objects are supported by your particular PDUs. The MIB is an enterprise level item. Again, it defines all possibilities. You have to walk the MIB against your system to determine what it supports. Today I'm dealing with two different systems. I have a pair of single phase PDUs with only 6 outlets, and they do both contain per inlet sensing and per outlet sensing. So there is still quite a number of objects, but it's the smallest PDU that we make. So I've chosen it to just save some time. I'm going to walk that MIB first using net SNMP. Didn't mean to hit enter, but we are walking the MIB. So at this point, that SNMP is looking at the MIB that I've preloaded at that particular location. It is going through, polling every object and responding back with the objects that are valid. And there is quite a bit, again, because even though this is only 6 outlets, it measures everything there is to measure at both the input level and at each individual outlet level. And it is also a switched PDU, so there is outlet control functions available as well. I'm not going to do this for the other PDU that we will look at later. The other system that I have up is 4 36 outlet PDUs, 1 primary and 3 link PDUs that also are switched and also have both per inlet power sensing and per outlet power sensing. And so it has quite a bit more objects versus what we're looking at right now. But this is a full MIB walk. It is running through everything possibly supported by the PDU and providing responses for everyone that is valid. So as mentioned earlier, if it was a switched a smart PDU, there would be far less objects. Should finish soon. I'm going to interrupt it so we don't waste any more time. But this is a MIB walk using NetSNMP. We'll just skip back to the beginning. We can see I've used a command that is making use of the MIB, sentry4.mib. And at the very beginning, we can see some pertinent details about the PDU, serial numbers. Oh, I walked the wrong one. I walked the 4 PDU system. So my bad. That's why it was taking so long. Wrong one. Okay, so just to cover the basics, at least with NetSNMP, you can always just issue a command such as SNMP walk and hit enter. It'll bring up a help menu. You have to specify the version. I'm using version 2, which in NetSNMP is always version 2. Or version 2C. M-M tells NetSNMP to reference the sentry.mib that I already placed in the proper location. I'm using a community string of public because a walk, an SNMP walk, only uses read access. And then in this case, I've specified the IP address of the PDU. This is the small set of PDUs. And then here we have the basics at the very beginning of the OID tree that we looked at. Every object will always begin with that number, and because it's a 4th generation PDU, there will be a .4 at the end. So this is telling it to walk everything within the MIB structure of a 4th generation Pro 1, Pro 2 series PDU, and this will not take as long. This is the smaller set. So that's a MIB walk. NetSNMP has identified everything that it can communicate with. That doesn't tell us what necessarily what you want to look for. It's much more useful. The other tool that I mentioned, which is the iReasoning MIB browser. This is much more friendly. I recommend it highly. It's going to allow you to identify objects quickly and their strings, either partially verbose or full digit-based, numbers-based strings. And the first thing that you do with iReasoning is you load the MIB. I've already done this, but there's an option to load the MIB. You find your MIB, in this case, sentry4.mib. I've already loaded it, so I don't need to do that again. It is a private enterprise MIB, so in this menu on the left, to find that MIB that you've loaded, you click on private. I'd previously expanded these items, but private, And then if you've loaded more than one MIB, you'd see additional. I've only loaded the server tech MIB at this point. So in order to perform a MIB walk using iReasoning, you can locate, well, you load the MIB, you go to the private, expand it, find Sentry 4, go to the Sentry 4 entry, whoops. Okay, yeah, and you will see that same string that I used at the end of the command line for net SNMP. We find that it identifies it automatically. We've got an option for a walk. And then this is iReasoning providing a result for all the possible objects returned by my 2 PDUs that are only 6 outlets. So again, we see all the details here. So the beauty with SNM or with iReasoning is that you can then quickly identify the object identification strings that you wish to use for particular objects. Let me switch back for a moment. So we just looked at a walk. I'm going to look. I'm going to do a subtree next. That's something that you'll find in iReasoning. A subtree allows you to look at just a particular table of objects rather than everything. The walk told us everything that is supported by the PDU. That's not as useful as narrowing it down. So the first thing that we're going to look at is how to get line current. Line current being amperage would be for a single phase, a single value. For 3-phase, it would be 3 different values. That is, if the PDU is a standalone primary PDU. If you have a link PDU, it could be 2 values for a single phase PDUs or 6 values total for 2 3-phase PDUs, and that goes all the way up to 1 primary and 3 link units. You could have 4 values if they're all single phase, or you could have 12 values if they are all 3-phase. So with iReasoning, you can expand your list. Lines is what we're going to look at for line current. Let me just jump back to a web GUI view. This is the PDU with only 6 outlets, 2 single-phase PDUs. We see a primary and a link at the units level. At the chords level, there's information available there. But what I'm going to show you first is looking up line current. So what we're going to look at by SNMP is the equivalent of what we are seeing here on the monitoring lines page. Currently, we've got 0 amps. I'm going to switch an outlet on and we'll see that change. And then we'll go poll that same object by SNMP. Okay, so at this point we see 0.34 amps at the line level. And if we want to get that same information from SNMP, at least using the iReasoning, we're going to expand the list, locate this particular table, ST4 lines. Let me clear this view. ST4 lines, and a get subtree is going to do a walk just of that tree. So this shows you the objects available at the line level in the hierarchy, and we can quickly find what we want to. Looking in the list, we are looking for line current. It's already come up and showed me 0.33. We saw, I think, 0.34 just a moment ago. It's a fan that fluctuates a little bit. As mentioned previously, I think I even showed you that example. It's showing 30 or 33, but as mentioned earlier, there is a units definition within the MIB. We are looking at line current. And we'll see that this is hundredths amp. So what that value means in reality, after adjusting the decimal point, 33 is going to be 0.33 amps, which is what we saw in the web GUI. All right, so from there, to identify the entire string, it's relatively simple with iReasoning. You can just click on that line. This is your full OID string. Did a walk earlier. In this case, it's the SNMP get command to get the value. And right now I'm using an entire digit-based or numbers-based string. And there we go. It shows you the integer is 33, and in this case, it actually tells you it's hundredth amps. So at this point, by net SNMP, you are aware that that it is 0.33 amps is the result. And that seems to say 10th amps there. I think that is something I will look into. Okay, so anyhow, that's an example. You could identify the entire OID string. In this case, I was looking for line current, but there's a different way to do it as well, at least using using that SNMP, similar to many other command line-based tools. You can use a string that includes a partially verbose instruction. Just copying and pasting from another screen. One moment. So rather than specifying the entire, did not copy, hang on. Okay, so rather than specifying the entire OID in a digits-based format, I can use the actual monitor table, the ST4 line current object by name, and then we see at the end of the string the 3 digits that are the indexes. And if we jump back and look at the OID tree, for line current, we see that we must specify a unit, a chord, and line. And in my example that I'm showing at this point, I am polling the first unit, the first unit, the first chord, and the first line, just like we see over here, unit, chord, line. So I am asking for the current from the primary PDU of the 2 PDUs, and we get that same result. Now, if we want to look at the link PDU, that will be unit 2, which I currently have no load on, so it's showing 0 hundredths of an amp. So we have found quite simply the full OID string, both in digits format and partially verbose. And we have demonstrated using it at the command line interface of NetSNMP. Okay, so let's talk about, you can't highlight that. Let's talk about controlling an outlet by SNMP. That is, if the PDU is a switched PDU and you wish to tell it to perform an action, such as switching on, switching off, or rebooting, which is to power off, count down a predefined delay, which defaults to 15 seconds, and then automatically power back on. We will do that using an SNMP set command. I'm going to start with iReasoning again. I'm going to jump to the outlets because we want to manage an outlet. We want to control an outlet. Within this table, we can locate what we're looking for. We're looking for the outlet control table. And then there is within that table an outlet control action. Outlet control action is what we wish to instruct to occur. So I've highlighted that. We clear this table. And I'm going to do a get subtree. It's going to run just the objects that are available for outlet control actions. These are our available objects. This is, as I mentioned previously, a 6-outlet primary PDU linked to a 6-outlet link PDU. So we have a total of 12 objects. The first digit for the 1 is the 6 outlets of the primary PDU. That's unit 1. And then we've got 6 more outlets for the 6 outlets of unit 2. In both cases, these are single corded PDUs. So the second digit in the variable binding index is a 1. And then we have the outlet number that we wish to choose, outlet 1 through 6 on the primary, outlet 1 through 6 on the link. Presently, I've got this fan blowing on me. I'm getting a little cold, so I want to tell outlet number 1 to switch off. I'm going to double click in that field. We immediately have the OID string in a digit format. It can be specified in a partially verbose mode as well. And in order using iReasoning to switch that outlet off, we have to use a set command. So I'm going to choose set. I had previously loaded the MIB into iReasoning, so it automatically has identified what my options were. Go back. We looked at them previously in the OID tree. We saw that you had the common options of, well, on being 1, 2 being off, reboot being 3. Those would be the most common. And we talked briefly about the Q options. I'm going to switch that outlet off, so I have to put in a value 2. That's an integer value 2. I'm going to tell it to go. It succeeded. I'm warming up. And we will take a look at the web GUI of that PDU. We now see that line current is down to 0 because there's nothing running through that PDU at this point. And we can take a look at the outlets and see that outlet number 1 is now off. So outlet control and identifying the integer values that are available and how to specify the either the OID or the digits is pretty simple. We can do it also by a partially verbose command. Now I could specify that entire string that we see up here. In this case, I've chose to make use of the defined object, the ST4 outlet control action object. And then I've specified unit A or unit 1, chord 1 because it is single chorded, outlet 1, and integer 2 is what I did previously. I'm going to switch the outlet back on with an integer 1. Success. Switch back, refresh the page, and we now see that outlet number 1 is now on, drawing current and blowing cold air on me. I will proceed to switch that back off with an integer value of 2. And we have switched that outlet back off. Okay, so another popular thing that you'll probably want to look for if you've deployed temperature and humidity sensors is to monitor temperature and humidity of the sensors plugged into the PDU. Let's take a look at just at the OID tree first. The hierarchy was system, units, chords, lines, phases, outlet or overcurrent protectors. We're at phases as we go down. Now we've got overcurrent protectors, and we've got branches, and we've got outlets, which we were just dealing with. And following outlets, we have sensor values. It starts first with temperature sensors, and then later we've got humidity sensor objects. So this is the text file, the OID tree. I'm going to find out what temperature my room is. These PDUs are right next to me. And so in order to identify the string to use, we're going to look for the monitor table. Monitoring is to get values. And we will find temperature sensor value as the object. Before I said, we have 2 variable bindings. We have to specify the unit and which sensor. In the case of Pro 1 and Pro 2 products, each PDU, whether it be a primary type or a link type, they each contain 2 combination temperature humidity sensor ports. So in the case of temp, the variable bindings, as again we'll see in the index list at the top, can be a 1 or a 2 per unit. So if I want to pull the temperature sensor of the second sensor on the link PDU, I would do the following. Nope, second unit, second sensor. And I missed something. I missed the 1. There's got to be a 1. It's the sensor ST4 temp sensor value object. We need a 1, and then we need 2 variable bindings. No. Let's make it easier. Switch to high reasoning, figure out what I'm doing wrong. We're looking for temperature and humidity, temperature in particular. So I'm going to expand the temperature sensors table. We want to go to the monitor table to obtain the values. We want temperature sense value. I have two PDUs, primary and link. Each of them has two temperature and humidity sensors attached. So what did I do wrong? Oh, wait, wrong object. Sense value. Silly mistake. Good learning lesson. Monitoring is a get function. I was attempting to set a value. It is a read-only object. I had it correct the first time. Whoops. And there we go. So that was one way to do it using partially verbose. We could also, using just the OID digit string. Use strictly an OID. And we're going to get the same response, basically the same response. Taking a look at the PDU to see that it matches, we're going to go to monitoring, to sensors. And that was the second temperature on the second unit. We've got a 22 here. I think that's basically what we saw, 21.9. So that's temperature. Humidity would be the very similar method to find the object, and then use an SNMP get to obtain the value of that object. Now we are going to look, we'll look a little bit later at a three-phase product and indexes for other values that you very commonly would like to monitor. And those will be, you definitely, with all PDUs, single phase or three phase, you always want to monitor line current. Line current is what is shown on the LED display of the PDUs itself. That directly relates to the current that is passing through each pole of the upstream facility level circuit breaker. So line current is what you monitor to make sure you are not oversubscribing a circuit. It's what you need to monitor to avoid tripping an upstream circuit breaker. It also gives you an idea if you're like underutilizing a circuit. So we will look on a three-phase product getting those values momentarily. You do have the ability to get phase current as well. Phase current is not necessarily an object that needs to be polled. It doesn't relate directly. In the case of a true Y wired PDU, an international PDU where outlets are wired line to neutral, phase and line are one and the same. So phase current and line current with an international or a domestic line to neutral wired PDU are the same. In the case of a three-phase delta PDU, such as where 208 volt is derived from in North America and a few other places, phase current and line current are not the same, but there's no real value to monitoring the phase current. However, there is value if the PDU is a Pro 2 product. There is value to monitoring branch current. Pro 2 products monitor current through each branch. That is, each branch has one overcurrent protector, so the branch current is the amount of current passing through each circuit breaker on the PDU. If it is a three-phase PDU and only 30 amp or less is only 3 branches, and it really is the same as phase current. But if it's a 60 amp PDU or bigger, you will have more than 2 circuit breakers per phase, or more than one, in which case you need to make sure that you are not oversubscribing one of the 2 or both circuit breakers. It's not possible really to oversubscribe both. But for example, a 60 amp 3-phase 208 volt PDU, you can get 35.65 amps, and there are 2 20 amp circuit breakers. You don't want to try to put all 35 amps on just one circuit breaker. You want to split that up evenly as possible. So we will look at getting branch current from a PDU in a little bit, and we'll look at the line current as well from a 3-phase PDU, just to demonstrate how the variable indexes work with 3-phase. But for now, let's just jump to one other thing, and that is seeing what a trap is. And that is if you've enabled traps to receive automatic information about events, such as an outlet switching on and off or a circuit breaker tripping. That is something that you had to have defined. You had to have defined a trap destination in the PDU, and I did that earlier. And iReasoning does have a trap receiver, even the free edition, personal edition. So presently, trap receiver in iReasoning is open. It's monitoring for inbound information on port 162. That's UDP port 162. I have configured my PDU with small number of outlets to send traps to the destination that is my laptop running iReasoning. Which is this address here. It is configured to send version 2 traps. We can send version 1 traps. We can send version 3 traps as well. The only thing to note with version 3 traps, they are a version 3 format. They are not encrypted. Now, for all other functions, if you utilize version 3 gets and sets and walks, all of that data is fully encrypted. Only trap data being sent from the PDU to the trap destination. It is in the version 3 trap format, but it is not encrypted. One other thing I want to look at here, configuration. If you're interested in being notified every time an outlet turns on and off, whether that be due to something like a circuit breaker tripping, or whether that be due to an authorized user logging in and switching an outlet off, there is a checkbox for state change logging that must be enabled. Out of box, the PDU does not send traps for when somebody instructs an outlet to turn on and off. I've enabled that so that I can demonstrate a trap being sent by switching an outlet on or off. I'm going to switch outlet 1 on. Let me jump over to trap receiver, and we see that it came up, outlet change event. We can look at information further down below and find that outlet AA1, that's as it is labeled on the PDU, or I'm sorry, in the web GUI. The variable index string is 1.1.1 because I switched on the first outlet of the first unit that has only one cord. So 1.1.1, and we see that the control state is on and that it is actually on at this point. I'm going to do a reboot and switch back quickly so we can see that arrive into the. Okay, I didn't switch back quick enough, but a reboot is going to switch the outlet off and then automatically switch it back on. See at this case that the outlet was then switched off, and 15 seconds later, it just switched back on automatically. So we've received another trap indicating the outlet has switched back on. So just wanted to quickly demonstrate traps. There's many DCM and SNMP based monitoring tools don't necessarily rely on trap data. A good number of them simply continuously poll objects from which they can glean the same information. But for those monitoring tools out there that are set up to receive traps and then take action or alert you based upon those traps, keep in mind that it is available from the PDU. I'm going to clear the table, do one other example of a trap, and that is I'm just going to manually trip a circuit breaker. So I tripped a circuit breaker on the first 6-outlet PDU, which in this case, there is just one circuit breaker. So we started with an OCP, overcurrent protector. That's the circuit breaker in this case. We have PDUs that use circuit breakers, and we still have some PDUs that use fuses. Overcurrent protector is either a circuit breaker or a fuse. And we see that it has notified us that the circuit breaker has tripped. And then as a result of that, all 6 outlets, that's what this outlet change event is. All 6 outlets, we've received trap notification that those 6 outlets powered through that circuit breaker have now also all switched off. We'll reset the circuit breaker. We see a change event where the circuit breaker has been closed, so it's back to, oops, it's back to normal. And then we've received notifications that 6 outlets have also switched all back to an on state. Okay, now I'm gonna switch. We're gonna take a look at 3-phase just to talk once again about the variable bindings, the indexes, and that is going to be this system, which, as I mentioned, was 4 PDUs total. It's 1 primary and 3 link units. It's got the same system hierarchy that we looked at earlier. So we've got a primary, we've got 3 link units. I also have an environmental monitor control unit connected, which gives you the ability to monitor a water sensor and 4 contact closure points and analog to digital channel. We're not going to look at that, but in the case of a 3-phase PDU, you'll see that we have a total of 12 lines because it's 4 3-phase PDUs. So we've got an absolute ID. Just looking at the first PDU, it's unit A, which would be in the terms of SNMP a 1. We've as the variable binding index. Then we've got the second character is an A, that is the cord identifier. In the web GUI, it's an A by SNMP, which is integer based. It is a 1. And then we've got 1, 2, and 3 is the lines. If we want to pull that data, we need to know what variable binding to specify in the command by SNMP. So we're going to start going back to lines because I want to look at line current. We want to go to the monitoring table, which is already expanded because I want to use an SNMP get to obtain that data. I want current information. So using iReasoning, I could run a get subtree and get the list, which I've just done. Alternatively, I can start with just adding. If I want to get line 3 of, what did I put a 1.1.3 at the end, so that's unit A, which is the primary PDU. The first chord is the second one, and then line 3. And instead of doing a, no such thing. Okay, maybe I did something. 311. Oh, nope. Okay. Switch to the correct PDU. My apologies. Okay, I could have cleared the table first. Do it again. So just by that OID alone, I have obtained line current from line 3 of the only chord of the primary PDU. These are sales demos that are online with nothing plugged into them, so the value is 0. If we use that same value by net SNMP, we'll also get the same overall result. We're going to do a get. And we are going to get an integer 0. If there were a value in there, I believe it would tell you the units measure, but in this case, line current, I'd have to go look. I think that's tenths of an amps, but because it's a 0 value, it hasn't told us the units. So hopefully everybody understands how the variable indexes work. Again, they are identified in the object identification tree, which you can look at manually, as we've done several times. There are those at the end of different values. Line current, we had a unit, chord, and line. I used a .1.1.3 to query line 3 of the first unit, first chord of the first unit. And let's take a look at branch current next, because I mentioned you're always going to want to look at branch current and line current. Branch current is to make sure you're not oversubscribing one of the PDU's own circuit breakers, rather than line current being possibly oversubscribing the facility level circuit breaker. So we want to look for the branch table. And if we're looking to monitor the current, we need to look for the monitor table. And we're interested in branch current. So we're going to use an OID that goes all the way back to a 3, and then 3 variable bindings. Before that a 1, before that a 3, before that a 7, before that a 1, and then everything before then we're already familiar with. I'm just going to make it easier on myself and jump to iReasoning. We want to locate the branches. We want to go to the branch monitor table, and let me clear the results. Branch current. No such. Is I used the wrong thing. Branch current without specifying a particular unit. In that case, it was unit. A branch would be unit cord and then overcurrent protector or branch. I was trying to use just a get, which require a full OID string, including the variable bindings. I've just changed to using a get subtree, and then we can identify what was available. So I should have used, a more expanded object at the top. So now I can use just a get. Let's clear that. And we get a value for just that one branch, current for that first branch of the first unit, the primary PDU, through the first branch of the first cord of the first unit, which is the primary PDU. And so we have in that process identified the OID. And we get a response. Now again, I could change it to use partially verbose name, making use of the MIB. I do need to MIB. And we should get the, nope, hang on. Yeah, put that in the wrong place. Now, I've got something wrong. We'll just skip ahead, but we can see that using the OID, we've identified the OID. If I were to get it correct, we could use a partially verbose string as well. So we've looked at obtaining OID strings for temperature. We've looked at line current for both single phase and three phase. We looked at branch current. We've looked at receiving traps. And so at this point, I'd open it up to questions. And if there's any particular object you'd like to look at, let's work through it, identify the OID, and go from there. Elizabeth, if you can open it up.
Yeah, absolutely. Thanks, Bruce. I just allowed access for microphone for all of our participants. So if anyone would like to come off of mute and ask your questions, or you can also put them in the chat and the Q&A as well. We'll give a few moments for that.
Okay, I think maybe our introduction mentioned looking at power, which would be active power or watts. That is something that a lot of people are interested in. Another object could also be energy. Active power, watts, is the dynamic power usage at the moment that you're polling that object. Energy is consumption over time, so kilowatt hours or watt hours, depending upon which level you're looking at. We could take a look at the unit with the fan that is blowing on me. And if we wish to find watts for that particular outlet with the fan, we would go to the outlets table. We go to the monitoring table for the outlets. We want to look at outlet current. I'm going to start with clearing the display. Just a get subtree is going to be every one of the outlets in the system. If I wanted to get just outlet number one, I could have done so, but again, iReasoning is very powerful. It gives you the subtree option. We can see that outlet number one is presently consuming 30, integer value of 30, which, as we looked at earlier, for outlet level, the units, the decimal digits adjustment is 2 places. So a 30 actually means 0.3 amps. And as we did see before, it's hiding under my share screen button. As we saw before, I've switched it back on and we're back to 0.30. So active power, very similar to gathering values for other objects. Energy is an option for kilowatt hours. That's not something you're going to be constantly polling, but it is an option that you could use for billing purposes. For example, you take one measurement at the beginning of the month or the beginning of a week, whatever period you want to bill by. Take one reading at the beginning, take one reading at the end, and then the delta between the two gives you a value that is the power consumed over that amount of time. And so that's something that you might be interested in if you're billing departments or customers based upon power consumption over time. You could find that at the outlet level. You could find that at different levels. If you actually wanted to bill by outlet, it would be in the monitoring table, and it would be outlet energy object. Clear the tree. And in this case, these PDUs are not brand new. I have been using outlet number one only for a little bit, just powering this fan for a short while. But I have had other devices connected to other outlets for some time. And so we see an energy value. Energy is like, it's an accumulator. It's like an odometer in a vehicle. So it's an ever increasing number, which is why when using energy values, you need both a start reading and an end reading in order to determine consumption over a period. Okay. I'm not looking. Did we have any questions come in on the chat?
We don't have any questions right now. So if there are no more, I think that we could wrap up unless you have anything else you want to go over, Bruce.
Well, I would simply say technical support at Server Technology is here for you. If you do have questions, you can reach out to us by phone. It's option number 5 when you dial in. Support@servertech.com is a way to contact us by email that will create a case automatically. You'll get a response back within typically 2 minutes or less. You'll have a case number. It goes into a common queue. One of us will grab it and respond back to you. So just keep in mind that if you do have questions about SNMP, we're here to help you out. Hopefully this session has been useful. And yeah, if there's nothing else, I will bid adieu and hope to see you at the next webinar.
Thank you, Bruce. I'd just like to also point out that the recording of this session will also be available on the PowerTips Live landing page, which is in the chat. I can put it in. And also that's where you can find recordings of previous sessions, such as the one we had back in May on TLS certificates. Thank you all.
Thank you.
Thank you. Bye.
Thank you.